It's the 31st of October, 2015, and this is episode 260. This show is intended for informational and educational purposes only. Cryptocurrency is new, exciting, and empowering, but we're not experts, just obsessed companions walking the road towards a more peer-to-peer future. On today's episode of Let's Talk Bitcoin, I'm here with Daniel Larimer, CEO of Cryptonomics and one of the creators of Bitshares. Daniel, thanks for being here.
Thanks for having me, Adam.
So you just released on, I believe it was, today's the 20th of October, and on the 13th, there was a fairly large transition from the Bitshares 1.0 project to the Bitshares 2.0 project. Why don't we, before we get into Bitshares 2.0, just remind people what Bitshares 1.0 was and kind of how we got from proto shares all the way to here. You don't have to get into detail, but just kind of like the highlights.
Bitshares is a project that aims to use blockchain technology to organize people to solve problems like a decentralized exchange. The creation of a decentralized exchange was the original purpose behind Bitshares, and it's had a long life through many transitions dating all the way back to 2013. When the idea was originally conceived. We've been through several different iterations, things like proto shares, or now we got the initial community bootstrap. Since then, it's really evolved through several iterations as we adapt to the market, adapt to lessons learned. And we've made a lot of mistakes along the way, but we've discovered a lot of things and we've done a lot of innovation at the same time.
So the recent rollout or the recent upgrade basically took Bitshares off of the original code base and put it onto an entirely different one that you and I talked about 6 months ago, maybe it was a little bit longer than that, called graphene. Why did you do that? Why was the decision made to abandon the earlier code base, and what was the advantage, or what advantages are you getting out of graphene?
So graphene is the library or the toolkit that we're using behind Bitshares. And in the process of developing the original version of Bitshares, we were under a lot of time pressure. We built it as quickly as we could to get something on the market to try it out. But it just wasn't a sustainable foundation upon which we could scale and add new features. So in the desire to accelerate future development and have the architecture that could expand and scale to the hopeful adoption, we had to re-architect things. So graphene is designed from the ground up with a whole lot of lessons learned, a whole new permission system that makes multi-signature transactions and accounts and user interaction a lot easier. It's designed with performance in mind. There's just a host of things that we've done to improve it, including the very consensus model behind delegated proof of stake. We've enhanced that to make more effective community consensus over complex issues.
I've always been very interested in the features that you guys are putting in, and the ones you just described are perfect examples of that. But the problems that I've always had with Bitshares have surrounded basic kind of usability. From what I can tell, there still seem to be usability problems. So can you talk about that, where the decision to put time, like how do you decide what to focus on, and how much is it about making sure this is as actually easy to use and usable as possible versus how much is it about making sure that you have these awesome features in there?
Ease of use has many different aspects. You've got the actual user interface, but the interface is often reflects the underlying technology. For example, with Bitcoin, the Bitcoin addresses and how you send those from person to person, it ends up showing up in almost all user interactions from all Bitcoin wallets. So we try to design fundamental features at the low level that allow ease of use at the higher level. So our multi-signature approach gathers all the signatures on the blockchain, and that makes multi-signature easier to use than is commonly found where you have to assign the transactions offline. So a lot of the features we add at the low level are actually done with the thought of how to make the higher level interface easier to use. And that's one of the challenges. If you design a lower level protocol that is super generic and flexible, completely scriptable, you still have to represent what that lower level protocol is doing to the user somehow. And we wanted to make the blockchain reflect the user's actions as closely as possible. Have the transactions be something that you could almost understand just by looking at them, rather than complex scripts that you have to have a computer to evaluate and interpret.
So Bitshares is a chain that uses the graphene library. There are other chains that will use the graphene library. Is this a change of kind of approach? Because I think I remember early on the Bitshares kind of thought was that the Bitshares chain would kind of be the home to all of these other things, and perhaps there might be side chains in the future.
Let's talk about the scaling issue in particular, because this is a subject that everyone likes to talk about, but no one likes to define the terms very well. There's different aspects to scaling. And this is something that I think is very important for the entire industry to contemplate. And that is, there's several dimensions. One dimension is throughput. Another dimension is latency. And then there's this third dimension of political scalability. You can have a really fast internet connection, but if you're trying to connect to a website hosted on Mars, it's going to feel really slow because the time between when you issue the command and the response gets back to you is so long. And so Bitcoin has a 10-minute latency on average before you get your first confirmation. And its worst case is even longer than that, right? It can sometimes be 20 or 40 minutes between blocks. The throughput is how many transactions you can actually get in that time. So in 10 minutes or 40 minutes, Bitcoin can get an average of 7 transactions per second into a block. You can make the blocks bigger and that will increase your throughput, but it will do nothing to improve the latency of the system. And then there's political scalability, and that has to do with how many people can be involved in the decision-making process. How many people have influence? How does that scale from small community projects to something as big as a nation or something that goes global? The political scalability of the system is a third dimension. With Bitshares and graphene, we've done a lot of focus on the latency aspect of this. And latency, I think, is very important for advanced smart contracts. It's incredibly important for markets, where if you issue a market order, you want to know as soon as possible, did that execute or not, so you can go do your arbitrage on some other exchange or trade in some other asset. But if you're on a blockchain based upon proof of work, where there's this uncertain period where you don't know if it's confirmed or not, it slows down ability to sequence events and know that your previous actions are locked in and irreversible. And so you can think of it as the difference between how many cores you have on a processor and the frequency of the processor.
And so when you say the frequency of the processor, that means the speed, basically.
Clock speed, yes.
One of the things about Bitshares is blockchain usernames, right? And you talked about multisig being more flexible in the new type of architecture that you have. I think that comes from deeply integrated usernames within the system itself. Is that correct?
That's part of it, yes.
Most blockchains don't have integrated usernames. You guys do. What are the other advantages of usernames in the system, and are there any downsides to using usernames in the system?
The primary advantages are that it's possible to communicate your username over the phone or in conversations or write it down on a business card. It's easier for you to remember your account name. Those are the pros. The downside is typos can be more frequent. They could cause you to lose funds that way.
So just because it's human readable, basically, that means that humans aren't going to be copying and pasting them necessarily, which means that you can have errors creeping in that way.
Yes. Bitcoin addresses, I can't tell you how many people I've talked to and how many times it's happened to myself where copy and pasting, it looks like just a bunch of noise and you think you got it right. So there's pros and cons with both. Our feeling is that from a usability perspective, copying random strings or having to use QR codes is a barrier to entry to the masses. The masses are used to bank account names that they know. There might be a routing number under the hood of their bank account, but they log in with a username and password. That's how people interact with websites. So the other benefit of names is it gives them personality. It gives you a way of, you're going to label your private and public keys anyway, just so you can keep track of who you're paying and whatnot. it provides some consistency to that, which allows your ledger to be readable and consistent across all your computers. So there are a lot of benefits associated with it. One of the downsides to the named account approach, potential loss of privacy. Your name is no longer random, so if you pick a name that is somehow associated with who you are, then people might be able to link that activity to you. All of that said, it's still possible to generate a random account name and use that and have more or less the same privacy you have on Bitcoin. I would like to add something on the privacy note that Bitshares 2 has. It's not available in the web interface, but it is available on the protocol and on the command line wallet for advanced users. And that is stealth blinded transfers. This is a level of privacy that exceeds what is available in the other coins. It's based on the technology created by Blockstream. So here, both the amount that's being transferred and who it's being transferred to is completely obscured, and there are no account names in this system. So it's the maximum level of privacy, but it comes at the penalty of ease of use. You've got to do more coordination between the sender and the receiver to make sure that payment is received properly.
Both Bitcoin and Ethereum support various kinds of smart contracts, and Bitcoin is adding more smart contracting capabilities all the time, where you basically can program transactions to have, rich levels of interaction. Where does Bitshares or the graphene library fall kind of between those two things? Are you more on the fully capable, you can do anything side, or is it more on the, limited language but powerful tools side with Bitcoin?
I'd say we're more on the curated side. We solve the adding features concept with changing the protocol by making hard forks to add new features easier to implement, easier to get consensus on, which means that we don't have to go for the unchangeable protocol, but an upgradable protocol. And our belief is that any smart contract that is going to be widely used needs to have a native implementation. So I think it's possible to do all kinds of things with these smart contracts in Ethereum or Bitcoin, but it's sort of like tying one hand behind your back and trying to, yes, technically we achieved the transfer of control and the behavior we wanted, but it wasn't done in a natural way for the particular application. It wasn't necessarily done in the most efficient way that it could be implemented. So I use the comparison between the App Store on Apple and the Google Play Store. The Bitshares stakeholders approve all the smart contracts that get added to the protocol. That said, one of the things that could be added to the protocol is a smart contract type features. We just haven't added it at this point because we believe that it's sort of a long tail of innovation. But the big applications, the things that really need to be done on the blockchain, should be done natively.
So you talked a little bit about political scalability earlier. Bitshares 1.0 used DPoS, or delegated proof of stake. I believe that the graphene system uses a more advanced variation of that and has a greater segmentation of roles, with the idea that if you split up responsibility and the ability to perform these roles amongst many people, none of whom have the ability to perform all of the roles, then no one individual or group of individuals are really responsible for any one thing that happens. And then you use the kind of stakeholders, which is to say the people who actually possess the Bitshares and then vote with those Bitshares. They essentially give mandate to various representatives to act on their behalf. Is that a good description of the system as you've designed, and what did I miss?
Yeah, that's a good high-level overview. I'd say we take a constitutional-style approach of separation of powers. We've got the witnesses, which are responsible basically for witnessing transactions and timestamping them and putting them into blocks. We've got the committee members, and they don't produce blocks, but they do get to change things like fees or network parameters, such as block size. But everything that they do is peer-reviewed by all individual users and goes through a waiting period where they can get voted out and any action becomes void. So those are two roles. And then we have workers, and workers can get hired by the blockchain to do implementation of new features that the stakeholders want. So if they want a new smart contract, they want something that's going to make the blockchain more competitive, then the whole blockchain can fund it without having to worry about donations or some people having to sacrifice so that everyone else can benefit. It really divides up all those roles. And then lastly, anyone can be a full node and be a validator, can basically check up on the network to make sure that all the rules are being followed. As I said, so there's no limit to the number of validators. There's actually no limits to the number of block producers other than the economic limits of how much is the network willing to pay and how quickly do you want to reach an irreversible consensus. I've done some analysis of these various dimensions of decentralization, of control, of power. And from where I said, I think Bitshares is doing the best in every dimension. We've got the most unique individuals actually producing blocks within any given period of time. So if you take within a 30-second window, how many people have participated in signing off on blocks, Bitshares has the most. There's one other role that we have in the Bitshares system, and that's the proxy. Now, this is like proxy voting in a corporation. What we discovered in Bitshares 1 was that there's a lot of voter apathy. Not everyone has time to follow all of the politics or evaluate all the people that are trying to do things, evaluate all the ideas. Not everyone wants to think about or even knows that they're able to make the best decision. So to solve that, you can simply set your account to proxy through someone else who you trust to make those decisions, which means that you can view proxy voters as sort of like a Congress of people where it's representation proportional to the weight. And that can allow the network to respond very quickly to changing conditions. And that's one of the main things that we wanted to make Bitshares able to do, is respond to dynamic market conditions. If the governments decide they want to shut down all the mining pools, how does Bitcoin respond? How long does it take them to respond? If there's a major issue that comes up with block size, how long does it take you to respond? That is the type of thing that we want the Bitshares network to be able to respond to quickly. So proxy or representative voting is how Bitshares achieves that.
It really seems like you've replicated a lot of, almost a political situation. You said the word politics, and that basically is what we're talking about here. You said that there is more participation on an individual level, and I assume you're talking about relative to mining pools, not individuals who run mining and participate in a pool. Why does that matter, and why is your system better?
In Bitshares, we try to make sure that every individual's influence is directly proportional to their stake. If you have one single bit share, you can either vote directly on who you want, or you can give it to someone who can decide for you. And you've got say proportional to how much you own. Whereas in systems like Bitcoin, if you own a Bitcoin, you have no say. If you're a Bitcoin miner, you can pick between one of the pools out there that's already out there, but economic forces mean that only if you can mine profitably do you have a say. In other proof of stake systems, the bell curve of the distribution of funds mean that the only people that can profitably virtually mine are those that have a large enough stake. Anyone with a smaller stake, they technically can run a node and produce blocks whenever their turn comes up, but they won't be able to do so at a profit, which means they don't get a say at all either. They're cut out for economic reasons. Lastly, just the ability of people to participate in the system without having to be technically proficient, without having to know how to run a server or maintain hardware or have good uptime. With workers and proxies and committee members, you don't need any technical expertise. All you need is to understand the concepts, to understand economics, or do whatever job you're going to do for the blockchain. But I'd say the one big thing we haven't discussed is another role in the network, and that is spreading the word, bringing in new users. And that's why Bitshares 2 has a referral program built into the protocol, which means when a new account is created, the network knows who referred them, and it knows how to divide up the fees of that referred user back to the people who referred them. So you bring someone into Bitcoin, and the network makes fees, the miners make fees, there's no income for you. With Bitshares, you bring someone to the network, and you get a cut of whatever revenue they generate for the network. And this gets to one of the hearts of Bitshares, which is to make sure the network is profitable. And profitable in the sense that the cost of paying all the witnesses to run the nodes and the workers to do everything should be less than fees earned. And the cost of user acquisition is an expense that all businesses have. And so the Bitshares network makes sure that cost of user acquisition is factored into the overall equation.
Today's episode of Let's Talk Bitcoin is brought to you by the L2B Network and Tokenly. If you're going to be in the San Francisco area next week, I'll be at the Future of Digital Currency Conference on Wednesday the 4th of November. I'm moderating a panel, although I don't know which one yet, and giving a talk entitled The New Token Economy, an Introduction, where I'll make the case to businesses and professionals on creating their own tokens and joining the global digital barter economy. For more information and tickets, and these ones aren't too expensive, visit futureofdigitalcurrency.com, and feel free to say hi to me at the event. On another note, the LTB network has been experimenting with providing podcasts in alternative audio formats and distributing via torrent. This is the sort of thing that we would love to provide, but only if there's actual demand from listeners who would use the services. If you're a user who would seed podcasts for the LTB network, or a user who would prefer to consume your podcast via torrent, send an email to adam@letstalkbitcoin.com and tell me your story to help make this decision. The magic word for today's episode of Let's Talk Bitcoin is share. That's S-H-A-R-E. Share. You've got until the 7th of November to visit letstalkbitcoin.com or the Let's Talk Bitcoin iOS app to enter it for your share of the listener rewards. Let's rejoin Daniel now. You and I first spoke about Bitshares just a couple of months after I had actually started Let's Talk Bitcoin. It really feels like you guys have fallen down on expectation management, to me personally. I've been watching the project kind of casually for the last year and more intensely for the first year before that. One of the things that I have felt pretty consistently about the project is that you guys have really amazing technology, and there's like zero question in my mind that when I use Bitshares, it is much faster, and because it's much faster, and because it confirms really quickly, and it works really well when it works, that it should have a much larger user base than it does. But it doesn't, because I feel like you guys, overpromise and then kind of underdeliver, and your technology is still better than other stuff out there, but it doesn't meet the goals that you have set for yourself. And so because of that, it feels like it's always in this kind of perpetual state of, well, this is just a temporary thing. This is the new system that's coming out because you tried to hit these goals but weren't able to hit the goals. I specifically bring this up in the context of a number I've heard tossed around a number of times, and I think it came officially from you guys, but I'm not sure, in that the system can support 100,000 transactions theoretically. Theoretically is one thing, but in practice, I read a article that you wrote maybe a couple of months ago, or perhaps it was a newsletter, that said that in practice, you guys can only actually do about 100 transactions per second right now because of realities of peer-to-peer technology, which are things that I don't think that you're actually working to change. I think it's kind of like you're just waiting for progress to kind of push along, and then that'll make it so that your system can work at that full throughput. And so, do you see what I mean here? Like 100 transactions per second is fantastic compared to any system that's out there that still maintains any sort of meaningful decentralization. But compared to 100,000 transactions per second, it looks like, a big failure. So I mean, do you get the issue I'm bringing up here?
Sure. And this is a question that's come up a lot. And the way I like to explain it is when we say 100,000 transactions per second, we're referring to the speed of the CPU. But even the fastest CPU is still limited by how fast the network is, right? So when Intel says that they can do so many million floating point operations per second on their latest CPU, well, that's only for applications that are highly optimized and under the assumption that you're not getting all the data that you're trying to feed the CPU from a network that's really slow. We identified that as the bottleneck, though. There are some tasks in blockchain technology that are inherently sequential. So we're talking about the core frequency, and just like CPUs, that's the one area of technology. We can add more cores. The individual cores, single-threaded performance, isn't growing as fast as the stuff that's multi-threaded. So we optimized for what we've identified as the bottleneck in the space, and then everything else can be done in parallel. Signature verification, faster networks, faster memory, more memory. Those are all things that are out there. So when we did our testing on a public test network with 30 plus participants distributed around the world, we are actually able to achieve over 1,000 transactions per second using low-end VPS systems. These are DigitalOcean machines with just a couple gigs of RAM. So we're doing 1,000 transactions per second without even doing any of the optimizations that could be made at scale, such as direct fiber optic links between the nodes that have been elected, more efficient networking protocol to reduce latency, GPS time synchronization to improve timing. There are a lot of optimizations that we know are possible that we're not really waiting for, as far as we don't need to wait for technology to advance. As soon as the network is saturating 100 or even 1,000 transactions per second, there'd be so much revenue generated that we could easily pay for both the development and deployment of the infrastructure to achieve 100,000 transactions per second without having to redesign the protocol in a fundamental way.
Okay, so the protocol itself is capable of that, although the current technology is not. And you used processors as an example. How good of an example is that? Because a processor, there are lots of things that you could do that don't require any sort of network connection or latency whatsoever, because they're just happening locally on your device. There are lots of use cases where you just wouldn't have to have that element at all. But with Bitshares, again, because it's this common ledger, that use case doesn't really exist. There's no reason why you would want to run an offline copy unless you're just doing it for cold storage, perhaps. I mean, maybe there is, but I'm not really seeing any.
At scale, in the computer industry, a CPU, fastest single-threaded performance CPU you can get, that is the limit of how many sequential order-dependent operations you can pump through the system at a time. You can't run a market where every bid or ask that's filled affects the orders that are available to the next bid or ask in a single market. That's all going to have to take place in a single thread on a single CPU somewhere. Even if you have many different computers all over the world running that same calculation, they all have to process the transactions. So one question is, how do you aggregate all the transactions, group them, sequence them, and then execute them? And the process of peer-to-peer networks, block production, all those things, that's all the grouping. But at the end of the day, all blockchains are limited by this. So we can scale up the network infrastructure. We can do parallel signature verification, have high bandwidth connections capable, because at 1,000 transactions per second and 100 bytes per transaction, you're looking at massive bandwidth requirements, not to mention the latency requirements in order to move that much data from one spot in the world to the other side of the world in a timely manner. So from a practical perspective, we know we can do 1,000 transactions per second without requiring excessive hardware because we've demonstrated it on our test networks in public. And we've scaled it back to 100 transactions per second just because we know we don't have the demand for it. It's more of a safety feature to prevent attacks or flooding attacks on the network.
You talked about the testnet with the DigitalOcean instances. DigitalOcean is a cloud computing service. So were these actually distributed around? I mean, like, is there latency in this system, or is like you got a bunch of instances in co-located locations, whether or not you intended for them to be collated, just because they're all on DigitalOcean? I mean, like, Is this a realistic comparison?
I use DigitalOcean to describe the specs of the machine, not necessarily the location.
Ah.
So we're talking about low-end VPS systems, but this testnet had systems from around the world involved in it. Some people at home on home internet connections, some people in China. We had a few in DigitalOcean on a wide variety of internet connections and hardware specs.
You talked about direct fiber optic connections between nodes that have been elected. One of the things that we've noticed over time with Bitcoin is that as the infrastructure requirements get greater, we actually see centralization because the barrier to becoming, a part of the system that enables it in the way that a miner or one of your delegates might, the barrier simply becomes higher, it costs more money. And with something like a direct fiber optic connection, then again, like that's a meaningful infrastructure investment that somebody would have to choose to make. So do you have any concerns about the system becoming less decentralized or less robust over time because of these kind of optimizations?
What we realized early on is that economic necessity forces centralization. And at scale, you have centralization. What we do is we manage it so that you can get elected and have a secure source of income for producing blocks before you necessarily have to make the investment in the hardware. It means that it's not just whoever is willing to make the investment and compete, they get it, right? Basically, you buy your way into control of Bitcoin. You can't buy your way into control of this network. You need both money and political support. That adds a lot of checks and balances. And it also means that once someone is an established player, they're not guaranteed to maintain that spot just because they have money. If they start misbehaving, they can lose their position and be out their entire investment. Whereas a Bitcoin miner, they can't be fired.
The proxy idea is particularly interesting to me because I can very much see something like that being useful. Okay, so let's change gears for a second and talk about other projects that are being built on the graphene technology, because I know that there are a couple of those coming out. And, like we've been talking about Muse, formerly known as Bitshares Music, for over a year now. So these are projects that have been in development for quite some time. When do you think we will actually start to see real projects using, Bitshares or the graphene toolkit?
The next blockchain to use the graphene technology is Muse, which is created by PeerTracks for the purpose of creating artist tokens and tracking payments for digital downloads. That blockchain you should expect to see within the next month. And it's using a snapshot of the notes, take on the same day that we upgraded Bitshares. Because notes used to trade, notes is the token on the Muse platform. They used to trade on the Bitshares blockchain as a asset created by PeerTracks. The same snapshot we used when we upgraded from 1.0 to 2.0 is when we took a snapshot of note, and that will be in the Genesis block of the Muse network, which should come out within the next month and have more or less the same features as Bitshares. Different allocation, different target market.
Why do this as multiple blockchains rather than having different tokens on the same blockchain?
It's not really my choice. I'd prefer to have everything on one blockchain, but PeerTracks and their whole business model depended upon having their own blockchain. And they started their business before we had the one bigger blockchain idea. So they're continuing with their same business plan.
I see. So what do you imagine that projects in the future, because one of the things about graphene was that you're interested in licensing it to not end users, I guess, but to people who frankly need this type of technological solution and who don't want to operate on the Bitshares blockchain. So what types of projects are you seeing coming in that direction? And frankly, what types of projects are you not seeing that you think are kind of natural uses for the platform, whether on Bitshares itself or on a spun blockchain?
We're getting a lot of interest from companies looking to have private internal blockchains or blockchains for other purposes that just, for whatever reason, are not compatible with Bitshares. Whether it's controversial reasons like gambling, the large stakeholders in Bitshares don't want to mix gambling with the blockchain. So that's an opportunity for someone to use the graphene technology to build another blockchain, because even if you implemented the feature, the stakeholders won't approve it to get it voted in. So you have no choice but to start a new blockchain. Other people want to offer financial incentives that would require diluting the stakeholders more than the Bitshares network allows through worker proposals. So if you're going to do some business model that needs to have a significant reallocation of the stake, you have no choice but to create a new blockchain. Or if you want to implement features that are just very unique to what you're doing, then that's another reason to have a new blockchain. So we're working with several different companies. I can't talk about all of it, but I'm very interested in seeing what's going on there. I would like to point out that the source code is open source in the sense that if you're using graphene for anything Bitshares related, it's basically BSD licensed. So as long as it's for the Bitshares network on the Bitshares, you can take, modify, redistribute, do whatever you need to do for Bitshares. The only restriction that we place on the use of the code is the creation of new blockchains.
In the last couple of years, there's been Proto Shares, there's been Angel Shares, there's been Bitshares 1.0, and now everything is moving to Bitshares 2.0.
They're all the same token. It's just gone through different names as it's been different versions. The original mined Proto Share, PTS, you imported your private keys into Bitshares 1 and you had Bitshares. And then now you take those same keys and you import them into your Bitshares 2 wallet and you've got Bitshares still. It's the same token. It's just a different software for representing it. If you have your private keys, any tokens that you have from any previous blockchain, you can access it still.
Okay, so you just import your old keys wherever they came from into the new client and you should be able to access your tokens. My company, Tokenly, it's funny because Bitshares offers so many things that I want to put Tokenly onto it. And I want to put the types of services that we've built for Bitcoin onto it. But I am frankly really, I'm very apprehensive about it because I don't know if now is the correct time to do that. I don't know if you're going to get traction this time. But the capabilities of what you've done, again, that's the point I guess that keeps coming back to me is there are so many things that we can't do because we have not only a 10-minute plus block time, but we have an unstable block time. This morning I was troubleshooting issues caused by more than 40-minute block times that were hitting just one after the other. It was ridiculous. And then also there are, other issues like transaction malleability that show up on a more popular blockchain, and perhaps you don't have that problem or perhaps you do. You don't. Okay, that's good. Is this the time? Am I going to get screwed if we try to develop a solution here? And how is it developing for Bitshares technology compared to Bitcoin? Because Bitcoin has a lot of eccentricities in it.
With Bitshares, most development is actually easier. The transaction structures are easy to understand. The API for communicating with the blockchain is very object-oriented. It's WebSocket based, which means we can push notifications and changes to you, and you don't have to poll. We've got a concept of block irreversibility, which is built right in, where you're guaranteed that after 2/3 of the witnesses have signed a block, it's not going to be possible to reverse it. Every node on the network is basically automatically checkpointing it, and that happens as fast as every 30 seconds or less. And for the most part, you can accept a single confirmation, which is just 3 seconds, and know that your transaction is through and it's there.
So a lot of the things that are built into Bitcoin is layers or utilities on top that we have to run now. These are things that are just kind of built in and we could access via API.
Yes.
So are there any things that are more difficult?
I'd be more than happy to talk with anyone who's trying to develop an application and figure out the best way to support your particular application. We've experienced a lot of the same gotchas at various points in time. I believe the last gotcha that you experienced was an inability to prove someone's balance because Bitshares 1 had everything were stealth addresses and the balances weren't tied to the accounts, and it just wasn't easy for you to do that. Under Bitshares 2, it's now very easy to prove your balance.
Okay, let's talk about that for a second, because one of the reasons why we couldn't do that was because usernames didn't actually have addresses associated with it. you would reference a user by their username rather than by a specific public key, because the public keys, all that stuff was being abstracted and handled kind of on the back end. And so all users ever dealt with was that. So how did you guys solve that? Did you solve it by simply making balances for users public, or is it a more complicated thing?
Effectively, balances for users are public. It's tied to their name. We recognize that under the old model, through analyzing the blockchain and patterns, it's possible to link balances together the same way you can link balances together in Bitcoin. And so people use Bitcoin today believing that their transactions are private. But unless you really know what you're doing, everything is getting linked together. Or you're jumping through a lot of hoops to try to prevent all your Bitcoins from being linkable through mathematical analysis of the blockchain. So we decided to do away with that illusion of privacy in Bitshares. And so balances are tied to account names. And when you're looking at the transaction history of the blockchain, you can see account name Dan sent Adam 100 Bitshares. And everyone can see that, unless you opt to use the stealth transfers, in which case no one knows who sent money to whom or how much it was. But from an ease of use perspective, a lot of people use public. The other problem we had with Bitshares was the voting mechanism. It left sort of a signature. Every time you transferred funds, who you're voting for had to go with it, or that stake couldn't be used as part of the voting system. So that was compromising privacy. With the new system, it's possible to count every single Bitshare in your account, whether it's in a market order or in a smart contract. If it's controlled by you, it can get factored into the voting. And that also means it's possible for you to do systems that need to look at, well, what is the balance? And you can create your own tokens on the platform. And you can, if you want to, disable the stealth transfers for your token.